So now let us discuss dielectric. Now, what is dielectric? Dielectrics are material which are basically poor conductor of electricity. We don't have free electrons in dielectrics. So no free electrons, they can just there can be induced electric field due to polarization. So how that happens is, if E naught B, so this is, let us say, a dielectric substance, I am applying an external electric field, that is E naught. Now due to this E naught, what will happen is, in this we have poles like the dipoles. We have already discussed that H2O, they are forming a dipole, like this is O, this is H, this is H. So overall dipole moment is like this, right? So these are like dipole, and due to this they experience force. These dipoles experience force in this external electric field and they get arranged. So on this, force is in opposite direction, and on this force is in positive direction. So positive, all the positive kind of moves in this direction and all the negative kind of moves in this direction. So due to this positive in this region and negative in this region, we get an electric field like this, and that is basically EP. Okay, so and EP be the electric field due to polarization. If we talk about the net electric field, now, so net electric field is basically E naught minus EP. So this is net is still in this direction only, and the net is reduced by K. So this is nothing but, this is basically the original divided by K. What is K? This K is called the dielectric constant. Okay, so it is reduced by a factor. So electric field is reduced by a certain factor, and that certain factor is called dielectric constant. Generally, dielectric constant is greater than 1. For air and vacuum, we can say that dielectric constant is equal to 1. Now, effect of dielectric on capacity of capacitance. Okay, so once we insert the dielectric inside a capacitor, so let C naught be the original capacitance and C be the capacitance after electric dielectrics. Then what happens is that originally here the capacitance is C naught. So I know that C naught is nothing but epsilon naught A by D. But what is the new capacity? So new capacity is basically, again let's do the same thing. If this is Q, this is minus Q. If this is sigma, this is minus sigma. Then basically you can say electric field over here originally was sigma by epsilon naught, but now it is sigma by K epsilon naught. Basically the electric field is getting reduced by that, and into this distance D will give me the potential difference. So I will say C is nothing but Q by V. V is nothing but sigma D by K epsilon naught, and eventually I get K epsilon naught Q by sigma, and sigma is what? Q upon, one second, sigma D, and sigma itself is Q by A. So this Q gets cancelled, this A goes here, so we get K epsilon naught A by D. And what about this? This was the original capacitance, and eventually we can write it is K times C naught. So if we insert the dielectric, and dielectric is having a dielectric constant K, then they will get rearranged. There will be induced electric field, due to which the capacity will also get reduced by a factor of K. So capacity will increase by a factor of K. So once we insert the dielectric constant K, then new capacitance is K times older capacitance. Now let us discuss a question. So this question says, the parallel plates of a capacitor having an area of 0.2 meter square and are 10 raised to power minus 2 meter apart, the original potential difference is basically 3000 volt, and now it decreases to 1000 volt when a sheet of dielectric is inserted between the plates and basically it is filling the full space of the plate between the plates. And now we need to compute the original capacitance. So for original capacitance, I would simply say that it is epsilon naught A by D. This is the formula for original capacitance, and that is epsilon is 8.85 into 10 raised to power minus 12. Area of plates is basically 0.2 meter square divided by the D, distance between plates, is 10 raised to minus 2. And now once we solve it, we get this into 2 is 17.7 and minus 10. So 1.77 into 10 raised to power minus 10. And capacitance, it is farad. So this is basically the capacitance, original capacitance of the capacitor. Now second part is the charge Q on each plate. So charge Q or is nothing but Q is the CV, and I am using this an original voltage. So initially the potential original capacitance was 1.77 into 10 raised to power minus 10 into original voltage between original potential difference between the plates was 3000, and that makes is 5.21 into 10 raised to power minus 7 coulomb. So this is the charge on each plate. One will be having positive, other will be having negative, but on each plate magnitude is 5.21 into 10 raised to power minus 7 coulomb. Next is capacitance C after insertion of dielectric. So we know that capacitance, new capacitance is nothing but K times original capacitance, but we don't know what is K, right? So another information has been given that it reduces, the potential reduces by a fact like to a 1000 volt starting from 3000 volts. So I am going to utilize that. So again the Q is equal to CV. This is the formula which I am using. But understand that when these are the parallel plates, you insert a dielectric in between. So when dielectric comes, the charge on each plate, it does not go anywhere. What changes is the capacitance changes and the voltage changes. So the charge is still remains same. So that will be 5.21 into 10 raised to power minus 7 is equal to C dash into V, which is nothing but 1000 volts, the new potential difference between the plates. And that gives me the new capacitance as 5.21 into 10 raised to power minus 10 farad. So this is the new capacitance of the capacitor. Next is dielectric constant K. So now we can utilize this C is equal to K times C naught. So K is nothing but the C upon original capacitance. So what is the new capacitance? The new capacitance is 5.21 into 10 raised to power minus 10 farad. The original one is 1.77 into 10 raised to power minus 10 farad. And if we see, this is a factor of 3. So the dielectric constant K is nothing but 3. Next is the permittivity epsilon of the dielectric. So this permittivity epsilon is basically the relative permittivity into the permittivity of free space. So this is nothing but your dielectric constant, and this is your same value 8.85 into 10 raised to power minus 12. Now if we multiply them that with 3, then what we get is, so 8.85 into 3, we get 26.55. So this is 26.55 into 10 raised to power minus 12. And what about unit? So the unit of K, see, F is equal to K Q1 Q2 by R square. So the K unit is Newton meter square per coulomb square. By this K is 1 upon 4 pi epsilon naught. So this has a unit coulomb square upon Newton meter square. So this is just a ratio. So this is dimensionless, and the unit of permittivity of that medium or dielectric is nothing but 26.55 into 10 raised to power minus 12 coulomb square per Newton meter square. So this is the permittivity of that medium, dielectric medium. And now next is the original field E naught between the plates. So if we talk about the electric field, how do we write electric field? Electric field is potential difference divided by the distance. Now if I want to get original electric field, I should use original potential difference. So this was 3000 volt and this was 10 raised to power minus 2 meter. And eventually that gives me 3 into 10 raised to power 5 and volt per meter. Next is the electric field E after insertion of the dielectric. So once we insert the dielectric, then it is basically the new potential divided by the distance is the new electric field. Now I will say that it is just 1000 divided by 10 raised to power minus 2. So it is just 1 into 10 raised to power minus 5 volt per meter. Now if we say which all quantities are changing. So once we are inserting the dielectric, what is happening is that E is becoming E by K. The V is becoming V by K. Like in this case, 3000 to 3000 by 3, that is 1000. The capacitance, that is becoming K times C, the new capacitance. And then the charge remains same because it has to be, like, it can't flow anymore. So like it is fixed on the plate. So the charge is fixed. It can't move as of now. It is not part of a circuit. So charge kind of remains the same.